Hello, this is Danial and Dylan assignment, Group 11, for final assignment, the Angry Bird. First, I'm going to talk about our script, and I'm going to show the games. First script that I'm going to talk is Slingshot Projectile, and yeah, this was my teammate work on this, and I'm going to explain his code. So first, we got a public mode and drag thing is set to true. So this public boolean to toggle whenever the object can be clicked or can be dragged, then we got boolean is being dragged is dragged whenever the object is currently being dragged by the user. And we got a private game object slingshot node. This is the reference to the anchor point of the slingshot is in the Unity editor. Then we got a maximum distance the projectile can be dragged away, and we control how strongly the projectile is going to launch. Then we got all the physics stuff and components. So physics object handling and physics shape sphere provide a shape and collision information, and slingshot projectile reference to himself. Then we got the vector 3. This is the track the velocity vector of the projectile when it's in launch. At the start, we got we disabling the object, physics object and physics shape sphere to ensure the projectile doesn't move or interact with the board until it gets launched. Then we got a self click, which is check if the left mouse button was clicked and cast a ray from the camera through the mouse position. Then we use a physics ray cast to determine if the ray intersects with the object collider. If it doesn't, then the method is gonna return to true. If the object wasn't clicked, it returned to false. Then we got move to mouse position. This is convert the mouse position from the scene space to the word space, and we calculate the new word position based on the screen position. And if the object is anchored to the slingshot, calculate the offset from the anchor point, limit the offset to the maximum slingshot length. And and we got update the object position either considering by the slingshot anchor or freely. For the calculate, we calculate the displacement vector and multiply it by the slingshot strength, navigate to the launch in the opposition direction, and we visualize the launch vector using a debug line. Then on the update, we got if the object is clicked and draggable, is set the is being dragged dragged flag. Then basically we enable the physics component to apply motion, assign the calculation velocity, and disable the script to stop any further updates. And yeah, now let's go. No, not this one. I'm gonna talk about physics shape sphere. So over here we don't have anything that much. We just have a radius and we get a scale update, and just talk about we return the shape dots for the sphere back, and we got Yeah, I don't see anything crazy over here. What about, oh yeah, let's go on the peak. This is the, this is what we, oh sorry, this on the peak we have thickness or softness. I'm gonna call it thickness through this video because I keep mess it up. This is the thickness of the peak, which is set to 10, and basically after we're going to talk about this in the physics engine too, but yeah, all over here we just got is a thickness of the peak, and it's gonna get destroyed if the thickness gonna be less than momentum. And yeah, let's go now on peak spawner. This is like a empty game object when we start a game, or I mean empty game object that just gonna spawn out pigs over there. What else we use a physics object, and physics object just hold all of the variables so that we want to change later on. And you can see as a drag, mass, gravity, scale stuff is over here. And what else? Oh, for the physics shape, I want to talk about. Oh, this script is extended with Group 11 physics shape. Let me open it. This is extended to this, so we just define the sphere radius and we update the game object scale based on the radius, and we ensure the scale adjusts whenever the radius is changed. Nothing crazy. And yeah, let's talk about physics engine now. Actually, on physics engine, let's go up. Okay. We got a private static reference to the slingshot in slingshot of the physics engine that ensure only one of the engine exists in the game. Then on the public static, we got this provide global access to the physics engine. If instance hasn't been set or yet it's try to find an object of type physics engine in the scene. And we got a delta time, which is the time step for the physics simulation is smaller. Delta time provide a higher acceleration but may require more power. And on the vector 3 we define a gravity force applied to the object with difficult set to the similar earth gravity. And on the list, this is just a list that store all the active physics object being managed by the engine. Then on the for each, this is through the list of physics object and remove any null object. Then we skip this. This is just skipping. This skipping the what's it called? Oh yeah, skipping the process for the static object. And on the new position and previous position, this is just store the position object current position for reference, and the new position is calculated new position using the object velocity and time step delta time. And there's a drag. Oh. This is our drag, which we're not even using it for this. Oh, sorry, excuse me. I want to talk about the stuff we are using in the game. And oh yeah, this. So basically over here, just we got a momentum, and when as I said, It's just a calculate a relative velocity object for a two object, and this is a momentum for each object is mass times velocity, and we check if either object is a peak by attempting the peak component is going to, if the object 8 is not already destroyed, is compare the momentum to the peak thickness. If the momentum extend the peakness, the peak is gonna get destroyed. And similar thing for the object B. So basically we're saying if the momentum is bigger than peak A or B thickness, is they gonna get destroyed in the game. And over here we just got collision sphere detection, and we just calculate the vector between the two sphere center, and these are for our lab stuff which help us to finish this assignment. And if the sphere overlapping, calculate the collision normal and the amount of overlap, and separate the sphere by moving each other half the overlapping distance along the collision normal, which I don't think so we even using any of this because all of these are for labs and we only have one bird. And yeah, actually no, we are using, so we are gonna move the sphere stuff in the game. So we're gonna move all of these white thing, and if they hit the peak, the green ones are gonna destroy them. So yeah, we actually are using those codes. What was it? Oh, and is there anything else for me to talk about? Talk about the slingshot, talk about this launcher and peak. As I said, they're getting thickness and they're gonna get destroyed. Spawner. Yeah, let's go through the game. I have to make sure this is over 15 minutes. Alright, the level, obviously we got slingshot, a bird that we could drag it, and we got the spear. The white ones obviously like an obstacle, like something that just cover our peaks, and the green ones obviously is a prefab that represent our peaks. Over here in the asset stuff, we got a material. Green for pig, yeah, red for bird, and yellow. I think this is by accident because we're not even using yellow for anything. And we got a prefab for pig. We got our scenes, our test scenes. So before we put everything in the main scene, we test everything in a different scene. And yeah, we got our scripts, and yeah, we can make camera slingshot, red bird, physics engine, slingshot again, and ground, and the level himself. Oh, I mean the level is holding all of this pig and spear in it. So let's play it again. We left click, drag, and you see the target position show bottom in the output, and in the up in the editor scene you could see the green line that is going to show you where the bird's going to land. That was not accurate, but let's try again. Let's try to hit a pig. There you go, I got two pig over there. And yeah, this is our game, and we already show when our mouse got release, and target position, mouse position, show everything. Awesome. And yeah, that was it. That was all about our assignment. Thanks for listening. Again, this was Group 11, Danial and Dylan. Group 11 final assignment. And yeah, I'm going to upload this right now, and have a great night.